Let me see who messaged me. Then from the okay, let me turn it off. All right. Okay, let me explain one thing. These 2 hours, and for the past many sessions of the 2 hours, you have learned different chapters. This is allowing you to understand what is the chapter about and what is the main key information inside the drawer, each chapter, because we divided into different drawers, right? However, by just attending the 2 hours would not make you exam ready. What do I mean by exam ready? So imagine Jingsam and Xuan Xuan, if tomorrow you are going for SPM exam, physics, most likely you will not do well. Although you did well in the MCQ, 10 out of 10, 9 out of 10, or 8 out of 10. But most likely you will not do well if tomorrow you are going for an exam, SPM exam, because you are not exam ready yet. Right. So the difference between exam ready and not exam ready is you need to be familiarized on the type of questions that you're going to answer, that you need to answer in the exam. In the exam, they are not just asking you MCQ. They're asking you different type of questions. So if you're not familiar with those questions, and if you're not familiar with the depth of those questions, then obviously you will not be doing well. So what is this 2 hours is helping you? So why? So you might be asking, if we are not going to do well, then why do we want to spend these 2 hours here to listen and to attend this class? The reason is simple. These 2 hours is allowing you to understand well what is the entire chapter is about, right, Eric? And also Yingsam and also Chuan. In only 2 hours, you'll be able to understand the chapter quite well, right? So that is the purpose of attending these 2 hours. And also these 2 hours, we are doing it in a very structured way. So you know what to expect from step 1 until step 10. And at the end of the step 10, or at the end of the when you're in step 10, you know that most likely you're going to get good results from the 10 MCQ because you understood the chapter well. However, not well enough to be exam ready, right? Not well enough to be exam ready yet. So what do you need to do? You need to continue on the revision, and also you need to continue, more importantly, on doing the past year questions, right? So when you do the past year question, without understanding, there are two versions. Let's say Jingsam version 1 and version 2. Jingsam version 1, you do the past year exam question without understanding the chapter. And version 2, Jingsam, is you do the past year question with a strong fundamental of understanding of the entire chapter. Which one do you think will do better and learn more from doing the past year questions? Obviously, it's the Jingsam version 2, right? Jingsam version 2 has a very strong fundamental of the chapter. You know how many drawers, you know what are the key informations and key concepts on each drawers. And then when you answer the questions, you'll be able to retrieve the right information and apply it as an answer to the questions, right? If you are not able to answer the questions, that means there are certain information that you still haven't learned yet. And then you will be able to pick up those new information and put it into the right drawer for that particular chapter. So that is the reason why you attend these 2-hour sessions, right? And that is what is going to help you to achieve, and how is it to achieve, as in benefit you, and how it will help you to be exam ready, right? To be able to score well or do well in your SPM exam. For dim sum, it's next year, right? So let's start with this measurement. Measurement is chapter 1. So as usual, let's be mentally prepared. We are going to start step 1. Let me just, okay, drawing is in. Okay, Jovin is in. All right, Jovin, welcome. You did not miss anything yet for the chapter, but you miss the part that I'm explaining how to be exam ready. If you're interested, then later you can re-watch the video because we recorded the video. All right, for now, we'll start the chapter 1 measurement, Form 4 chapter 1 measurement. So let's be mentally prepared to follow step 1 until step 10 in the 2 hours. All right. So step 1, we have 5 drawers. And the drawers' names are measurement, base quantities, derived quantities, scalar versus vector quantities, and graph. So what is the story that will help us to remember the drawer name in sequence easier? Me, as in me, M-E, the bass drummer, meet Scarlett and Victor. If you have friends called Scarlett with the name Scarlett and Victor, then excellent. Riding giraffe. So me, the bass drummer, meet Scarlett and Victor riding giraffe. There's different type of drum. You have side drum. You have so many type of drum. One of the drum is called bass drummer. This big round drum. If you are familiar with it, then you can understand what I'm trying to say here. Now, there is a animated video on a few seconds. Let's watch the video together, and then that will help you to remember this story easier, right? Where is it? Okay.
Form 4, Chapter 1, Measurements. Me, the bass drummer. Meet Scarlett and Victor riding giraffe. Draw 1.
Okay, I hope everyone can watch, you're able to see it and also listen to the video. Right, anyone? Good. As long as there is one, then I think the rest is able to watch the video and listen to the sound. All right. If not, then let me know. Okay, I will. Yes, what I'll do is I will also put this in the chat, just in case you need the link. Right. Okay. Now let's continue on step 2. Step 2, there are 5 drawers, and there are a few key points, and we will take a few minutes to read step 2. So let's take 2 minutes. Or 3 minutes. Let's take 3 minutes. Let's start now. From drawer 1 until drawer 5. If you don't understand fully, that's fine. And that's normal. Okay, you should be in drawer 4 now. One more minute. Thirty seconds. Ten seconds. All right. For those who is trying to remember or memorize this 7 base quantity, don't worry about that. You just need to know there are 7. I will help you to remember it using a story, right? And it's all about measurement. Then you have base quantity. You have derived quantity, because derived quantity is being derived from the base quantity. Then you have this different type of quantity, which is scalar and vector. Basically, scalar is having magnitude and vector is having magnitude and direction. Then how do you interpret more information using graph? And that's it, right? So as of now, you should know there are 5 drawers, and you should know there are a few key information inside each drawer, and that's it. If you do not understand fully all about this information, that is fine. But I think it's easy to understand, because this chapter is relatively easy. Unlike this morning, I was teaching quantum physics. That is more difficult compared to this chapter, right? Now, let's start with step number 3, and I'll repeat. I think I repeat this almost in every class. This step number 3 is an extension version of step number 2. So when you read it, if you realize you have the same meaning of measurement, point number 1, point number 2, point number 3, before you move on to drawer 2. Right. So the only difference here is this is more detailed. This is less detailed. And you should be expecting your understanding for drawer 1 to level up, to increase from level 2 now to level 3 after reading this. So let's take 2 minutes to read this, because I think this is easy to read. Okay, you can start now. 2 minutes. Drawer 1 until Martin's surface. All right, by now you should be in point 3. If you have finished reading it, you can read it again. to make full use of your time. All right, drawer 1 is done. Let's hope you have a little bit more understanding on what is drawer 1 compared to 10 minutes ago. Now drawer 2, let's also do 2 minutes. From drawer 2 until this mole. Right now it should be in point 2. Forty seconds. Okay, time's up. Now let's move to drawer 3, which is a bit difficult, but it's not too difficult. Don't try to memorize these formulas. It's of no use. Just need to understand there is such thing, and that's it. Let's do 1 minute. Let's do 2 minutes also. Right. No need to memorize the formula. Just need to understand the concept. That's it. Derived quantity is from base quantity. 10 more seconds. All right. Drawer 4. This one. I think 1 minute is enough. Let's do 1 minute. Drawer 4, 1 minute. And drawer 5 also 1 minute. So you should be in drawer 2.2 now, minimum. You should be in 0.3 now. Okay, let's continue to drawer 5. Drawer 5 is a bit long. I'll give you 2 minutes. So I'll add 1 more minute later. Okay, let's start here. Drawer 5, 2 minutes. Okay, you should be 0.2 now. One more minute. Forty-five seconds. Twenty seconds. All right. Now let's move on. So now your understanding level should be in level 3. And we are trying to move and improve it to level 4 by going into step 4, FAQ. So let's do this question 1 and 2 for drawer 1 for 3 minutes. Let's start now. Okay, you should be in question 2 by now. Oh no, 3 minutes. So you should you still have time, don't worry. Okay, you should be in question 2 by now. $40. 10 seconds. All right, let's go to drawer 2, question 3 and 4. I think let's do 2 minutes only. 3 minutes I think is too long for this. Okay, let's start now. Drawer 2, question 3, question 4. Okay, you should be in question 4 by now. $20. 10 seconds. Thumbs up. All right, let's move to drawer 3. All right, 2 minutes, start now. Okay, question 6 by now. 30 seconds. All right. Draw 4. Okay, almost there. 2 minutes. Let's start now. Scalar and vector quantities. Remember scalar and vector. Writing on giraffe. Question 8 by now. I hope this is not too easy until you are so sleepy. Let's hope everyone is still awake. 20 seconds. All right. Last one. Same drill. Question 9, question 10, 2 minutes. Start now. This is the giraffe. Remember the giraffe? Okay, you should be in question 10. The last one, the giraffe, the long-necked giraffe. Twenty seconds. All right. Now, let's do a quick review. If you still remember the story, you, the bass drummer, meet Scarlett and Victor riding giraffe. Me, as in the measurement for drawer number 1. Base means the base quantity. Drummers means derived quantity. Scarlett and Victor, scalar and vector quantities. Giraffe is graph. Okay, so we have already went through step 1, 2, and 3, and 4 to help you to remember what is, or to help you to learn, not remember, learn what are the key information inside each drawers. Now we'll go to step 5 to improve your level from level 4 to level 5. Level 5 is when you are taking an MCQ of 10 questions, you should be able to answer 5 correct answers. Right? 5 correct answers is not high. It's not a high expectation. So don't set yourself to a level that is a high expectation where you're expecting you to understand fully. Right? You just need to understand, you think, you feel that it is 50%. Right? 50%. So let's do 2 minutes for this drawer 1 until the system. I'm going to slow down a bit gradually as we move. Let's start now. Okay, I'm going to slow down gradually. You should be in point 2 now. You should be in point 3 now. Twenty seconds. Right, 10 more seconds. Okay, your understanding level should be in step 5, no, level 5 for drawer 1. Right, now your drawer 2 is still 4. We are trying to make it to 5. 2 minutes starts now. You should be in point 2 now. 30 seconds. Fifteen seconds. Okay. Drawer 3. Right? Let's start now. Level 5, okay? Improve to level 5. That is your intention of reading this. Derived one. Base problem. You should be in point 2 now. Let me scroll down a bit. Fifteen seconds. All right. Drawer 4. Drawer 4. Okay, let's do the same thing. 2 minutes. Start now. The Scarlet and Victor. Okay, you should be in point 3. Okay. Last drawer. The giraffe. Same thing, 2 minutes. Let's start now. Okay, it should be 0.2 now. Fifteen seconds. All right. This time we will not go for a break. We will continue because I think it's not too heavy. Okay. Now, step 6. Step 6 is to improve you from level 5, which you were now, you were in just now, and to level 6 that you're going to be soon. And step 6 is to create story for each drawer. So we have 5 stories over here. So I'll tell you my story. Let's see whether it makes sense to help you to remember and understand what are the key points in drawer number 1. You remember the drawer number 1, you have these 3 key points. So let's see. Magnet pulls you into matrix and become imperial emperor. Right? Magnet pull you into matrix and become imperial emperor. So why magnet? Magnet is the magnitude. Pulls you. Okay, I intentionally use U rather than Y or U is because I want to represent unit. And into a matrix. So matrix sounds a bit similar. And become imperial emperor. So he became imperial emperor. We're going to watch the video, the animation later. So let's continue until start drawer 5 on the stories. Then we can see the AI video. So base quantity, you remember I told you that I'm going to help you to remember the 7 base quantity. Little monkey takes tea in lighted magic. All right, little monkey takes tea in lighted magic. Little is the length, monkey is mass. If you look at these 7 quantities. Take is time, this temperature is T. Usually current is I, the symbol is I, so I use I. You can use A, but you have to change the story here. In lighted magic. Lighted is this light, okay, luminous, CD, and magic, mold, substance. Okay, that is my story. You can change to your story if you think there are another story that makes more sense for you. Then derived quantity is base plus base. I don't know how to make it into more simple story rather than just base plus base, because derived quantity is being calculated or derived from base quantity. So base plus base equivalent to derived. Scalar versus vector quantities. So you have scalar has magnet, vector has magnet, and compass. So what does it mean? So on this part here. So scalar quantity is magnitude. So she has magnet. She's holding a magnet. And Victor is holding a magnet plus a compass, because vector quantity is not only magnitude and also directions, right? So last one is graph as a draw 5. Paul and me walks in the same direction together into the universe. So you and your Paul walks into the same directions into the universe. And then interpole joins to walk up the slope. What does it mean? Let me see if I remember. I did this last 2 weeks. Right. Purport is, yes, purport is the proportional. So there's this proportional and inversely proportional relationship in the graph. Proportional means if there are two variables, they are proportional to each other, that means they are increasing in value together, right? Proportional. So in the same direction means the graph is in the same direction. That means going up to the positive direction. So this purport is to help me to remember proportional, right? And into the universe. Into the universe is the opposite of proportional is inversely proportional, right? So inverse sounds like into universe. So you in the graph, you have proportional and inverse proportional, inversely proportional. So that's how I get this story. Interpol joins to walk up the slope. So the Interpol, the police, the Interpol police, they join me and my purport to walk up the slope, right? This guy, Interpol police. Interpol is to represent the interpolation. So when I know there's something called interpolation, obviously it's easy for me to relate extrapolation. Right. So what is interpolation and what is extrapolation was being described in the previous step just now. Right. And walking up the slope is gradient. Gradient is also one thing that is important for you to analyze the graph. Right. That's one characteristic of the or one property of the graph that is important. Right. So that is the story. That is my story, and I turn it into animations. So let's watch from start. It's only 1 minute and 17 seconds. I'll start now.
Form 4. Chapter 1. Measurements. Me, the bass drummer. Meet Scarlett and Victor Ruff. Draw 1. Measurement. Magnet, pull you into matrix. And become Imperial Emperor. Draw 2. Base quantities. Little monkey, take T in lighted magic. In lighted magic. Draw 3. Derived quantities. Base plus base. Draw 4. Scalar versus vector quantities. Scarlett has magnet. Victor has magnet and compass. Draw 5. Graphs. Popo and me walks in the same direction together into the universe. Interpol joins 2 walks up a slope.
All right, this is the picture. Now, let me just explain a little bit more here, especially for Jing Sam, Jovin, and Xuan Xuan, and also even Eric, right? If tomorrow you are going for SPM exam, just imagine you are going to SPM exam tomorrow, right? And there are how many chapters here for physics? There are 13 chapters, 6 chapters in Form 4, 7 chapters in Form 5. In total, 13 chapters. And these 13 chapters, tomorrow, you need to take physics exam. Just imagine, right? And you need to answer many questions. I think it's about 2 to 3 hours. You have to sit in the exam hall and answers all the questions in that 3 hours. Just imagine it's 3 hours. How are you going to do that? This learning method is going to help you to do that easier. And how? With this picture is to explain in a very fast way for this chapter, Form 4, Chapter 1. And you have 13 of this chapter, 13 of this picture, right? And if you train yourself enough to draw these 13 pictures, and that 13 pictures is going to help you to understand and remember what is being taught in each of the chapters. And that means when you sit in the exam tomorrow, SPM exam, physics for 3 hours, immediately when you see these questions, you are able to refer to which chapter, whether it's Form 4, whether it's Form 5, or whether it's which chapter in which Form 4 and Form 5, and then which drawer. Then you'll be able to answer and provide the answer as much as you could for that particular questions, right? So that is how you need to be exam ready. This picture is helping you as one minor step to be exam ready, to be able to provide the answer that is needed in the questions, right? So you need to have this picture. Remember this picture for the 13 of them. And then you need to be able to link all the content that you have learned for each of the drawers by just looking at the picture. Okay, because you are not able to bring this link, this YouTube link, to help you to remember the content, right? Yeah, and also, obviously, you will not be able to write all this down for the 13 chapters, right? The only thing that is helping you to remember easier is this picture, right? So that is to be exam ready. So that is step number 6. Step number 7. Now that is the quiz. So how do you do this? You read the questions, you form your own answer, then you compare with the answer that's being provided. If there is answer that is here, that is being provided that you do not know, then intentionally pick it up and put it into the right drawer of your drawer, right? So let's do 2 minutes for 4 questions. Let's start now. Okay, you should be in question 2 now. Okay, you should be in question 3 by now. Should be question 4 by now. Ten more seconds. All right. So let's take one example. For example, question 3, define base quantity and provide 2 examples. Remember the story? The little monkey takes in tea in lighted magic. You can immediately give 7 examples, not only 2, by just having that story in your mind, right? So that is the power of that drawing or the picture or the story. Now let's do Question 5 until question 8, 2 minutes. Start now. Question 6 by now. Question 7. Oops. Question still question 7 is. Should be in question 8 by now. Twenty seconds. Ten seconds. Okay. Okay. 9 and 10 in 1 minute. Let's start now. Okay. Should be almost done. Let's do it another 10 seconds. Another 5 seconds. Okay, time's up. Now, your understanding level now should be level 7. Level 7 should get 7 out of 10 question correct. Right. So now let's move on to the video. I think video is your favorite part.
Hey everyone, welcome back to The Explainer. So glad you're here today.
Okay, I hope everyone can watch and also can hear what the lady is speaking. Can anyone just one show of hand? You have no problem?
Because we're about to do something pretty incredible. We're going to decode the physical universe.
Okay, Jing Sam, good. So let's start from scratch, from the start. 6 minutes. Let's do it now, and intentionally know that this is being designed. This video is being designed in a way following our drawer, right? So when it reach drawer number 1, I need you to focus that this is drawer number 1, and if you can remember the story and the picture, then it's even better. Let's start now.
Hey everyone, welcome back to The Explainer. So glad you're here today. Because we're about to do something pretty incredible. We're going to decode the physical universe. Have you ever wondered how physicists actually describe reality? Well, it all comes down to the fundamental building blocks of measurement. Today, we're unpacking the exact tools and concepts scientists use to translate our messy, beautiful real world into precise, universal numbers. To do that, we're going to open up a sort of 5-drawer toolbox. First, we'll look at the meaning of measurement, then check out the 7 base quantities, see how we build derived quantities, compare scalar versus vector quantities, and finally, master some key graph analysis skills. Let's get right into it. All right, drawer 1, the meaning of measurement. So let's frame this with something you probably use, every single day. How does your GPS know exactly where you are on the map? It's not magic, right? It's actually a physical mystery solved by incredibly precise measurements. It determines your location simply by measuring time and distance using satellites. And this brilliantly illustrates exactly why that accuracy matters so much. Whether NASA is calculating the exact trajectory to launch a rocket into space, or say we're tracking the recorded time of 11.87 seconds for a Paralympic sprint champion like Mohammed Rizwan Puzi, measurement determines exact locations and outcomes. I mean, a tiny error, that means missing the moon entirely or missing out on a world record. There's literally no room for error. Now, a physical quantity breaks down into two non-negotiable halves. To accurately measure anything, you absolutely need a numerical magnitude, that's the how much, and a specific unit, the of what. Think about it. Saying a mountain is 4,095 means absolutely nothing. But saying it is 4,095 meters high, well, now you've given it physical meaning. But, simply having a unit isn't enough. We actually have to agree on which ones to use. We see this clash all the time between the globally familiar metric units like centimeters or kilopascals and imperial units like inches or psi on your tire pressure gauge. For scientists to communicate accurately across the globe without, catastrophic misunderstandings, standardizing these units is absolutely vital. Actually, just ask NASA. They once lost a $125 million Mars orbiter simply because one team used metric and another used imperial. Crazy, right? Okay, moving on to drawer 2, the 7 base quantities. I want you to think of base quantities as the fundamental flour and eggs of physics. By definition, a base quantity is a physical quantity which cannot be derived from another physical quantity. They are the absolute bedrock. You literally cannot break them down into anything simpler. So the crucial point here is this definitive list established by the SI system. Out of the infinite complexity of the whole universe, there are only 7 fundamental quantities we need to measure everything. We've got length, mass, time, thermodynamic temperature, electric current, luminous intensity, and amount of substance. Master the SI base units, and you essentially hold the keys to physics. Let's pop open drawer 3, building derived quantities. This is where things get really fun. If base quantities are the flour and eggs, derived quantities are the fully baked cake. They are formed entirely by describing physical quantities in terms of base quantities through simple multiplication or division. Let's visualize this. Imagine measuring the length of a box. Okay, that's one base quantity. Now multiply it by its width, which is just another length. Then multiplied by its height, a third length. By multiplying the base quantity of length 3 times, we magically derive the entirely new quantity of volume. In fact, almost every complex concept you hear about in physics works exactly this way. Take a look at density. It's really just mass divided by volume. Velocity, that's just length divided by time. Even force, which we measure in newtons, is simply a mathematical combination of kilograms, meters, and seconds squared. The whole shebang traces right back to those original 7 base units. All right, drawer 4, scalar versus vector quantities. Picture some students out on the field during a PE lesson. In one scenario, the teacher instructs them to run 50 meters. And they just scatter, right? Running a distance of 50 meters in any random direction. But in situation 2, they are running 50 meters straight toward a specific target, like a tree. This brilliantly illustrates the stark contrast between 2 distinct types of quantities. A scalar quantity, like that first group running a simple distance, well, it only cares about how much, the magnitude. But a vector quantity, like the second group running a specific displacement, demands to know how much and in which direction. So speed is a scalar while velocity is a vector. Make sense? And finally, drawer 5, mastering graph analysis skills. So we decode all these relationships we've been talking about through graphs. The simple shape of a graph instantly tells us the exact relationship between 2 physical quantities. A straight line through the origin screams directly proportional. A rising curve tells us y increases as x increases, while a falling curve tells us they have an inverse relationship. Basically, the shape is the story of the data. But just reading the shape is only step 1. To truly analyze an experiment, you need 4 essential skills. Calculating the gradient, or the slope, often reveals a hidden derived quantity like acceleration. Calculating the area under the graph might reveal distance. Along with interpolation and extrapolation, these skills are basically like reading the ultimate blueprint of a physics experiment, allowing us to form a solid conclusion and complete the experimental method. So we've built reality from the ground up using length, mass, and time as our foundation. But to truly test your understanding, I want to leave you with this provocative question straight from our source material. What constraints would physicists face if force, area, and time were chosen as the new fundamental base quantities of the universe instead of mass and length? It's a massive shift in perspective that completely challenges everything we just learned. Think on that for a bit, and I'll catch you in the next explainer.
All right, that is step 8. Let's move to the last step, or the second last step, step 9, before we go to the MCQs as step 10.
Imagine trying to build a modern city or coordinate global air traffic without a universally agreed upon definition of an inch or a meter.
Oh, it would be pure, unadulterated chaos.
Right. Welcome to today's deep dive. We are unpacking the fundamental language of the universe today, which is, well, measurement.
Yeah, and our mission is to give you a shortcut to understanding this invisible scaffolding that lets us quantify reality.
Exactly. We're stripping away the static so you get straight to the core insights.
The irony is, we take measurement completely for granted in our daily lives. I mean, a measurement isn't just a number floating in the ether.
That needs context.
Exactly. It's a very specific pairing. You have a magnitude anchored to a unit, like if your car's dashboard says 100.
That implies wildly different realities depending on whether the unit is kilometers per hour or miles per hour.
Yes. And the stakes for getting that pairing wrong are surprisingly high.
Oh, totally. Just think about the GPS system on your phone. To pinpoint your exact location on Earth, it relies on, incredibly precise measurements of time and distance beamed from satellites.
And if those units are jumbled, the whole system collapses.
Which is why everyday tools, like a standard tire pressure gauge, still force us to navigate both metric kilopascals and imperial psi. We're constantly translating reality just to function.
Right, which is exactly why the scientific community had to force a consensus. In 1960, a global agreement in Paris established the International System of Units, the SI system.
Wait, hold on. 1960.
60.
We were literally in the middle of the space race. We split the atom and built nuclear reactors before we had a globally finalized universal baseline for a simple meter.
I know, it sounds crazy.
How did international engineering projects not constantly crash and burn?
Well, they actually did struggle with localized discrepancies. That is what makes that 1960 agreement such a watershed moment. It wasn't just about convenience.
It was about standardizing the tools.
Exactly. It was about finally establishing the foundational alphabet of physics. They locked in 7 irreducible base quantities: length, mass, time, thermodynamic temperature, electric current, luminous intensity, and amount of substance.
Wow. Okay, so those 7 base quantities cannot be derived from anything else.
Nope. They are the absolute bedrock of physical reality.
Okay, so if those 7 base quantities are the core letters of our universal alphabet, then derived quantities are the words we spell with them.
That's a perfect way to look at it. We build complex concepts by multiplying or dividing those core letters, like volume is just length cubed.
Okay, let me push back a bit, or maybe just check my understanding. Are complex units of force, like a Newton, essentially just base units wearing a trench coat?
I love that. Yes, the trench coat analogy holds up perfectly here.
Underneath, a Newton is really just mass, length, and time structured together, right?
Precisely. A Newton is a derived quantity acting as a necessary shorthand. You are describing a dynamic physical interaction kilograms times meters per second squared, without having to spell out that entire mathematical phrase every single time.
Okay, that makes sense. But spelling out the amount of something only gets us halfway there.
Right.
The next major hurdle in quantifying reality is pinning down intent or movement in 3-dimensional space.
Yes, the massive leap from scalar to vector quantities.
Right.
And it is a vital distinction. A scalar quantity only gives you magnitude, just the raw size or amount. But a vector locks in magnitude and couples it with a highly specific direction.
Let's ground this in reality for a second. Say you are driving to Kodakinabalu.
Okay, road trip.
You cover a total distance of 333 kilometers, cruising at a speed of 80 kilometers per hour. Those are purely scalars, right? Just raw amount.
Exactly, no direction attached.
But if you hit the gas to pass a truck, applying an acceleration of 1.2 meters per second squared toward your destination.
The moment that specific direction is introduced, you are operating with a vector.
Got it.
And to map out how all these scalars and vectors interact dynamically, scientists rely on graphs.
But graphing isn't just about, plotting data points for visual flair.
Oh, definitely not. It is about decoding the hidden rules governing those interactions. When we analyze a graph's shape,
Like distinguishing a straight linear progression from a curve passing through the origin.
exactly, when we do that, we are literally watching physical laws manifest visually.
Which perfectly explains the scientific obsession with repetition and experimental methods.
Oh, absolutely.
Like, take the classic example of timing a simple pendulum. You don't just measure one swing, right? You time 20 continuous oscillations and average them out.
Yeah, you're not doing that just to find a single number.
You're actively smoothing out human error. So the resulting graph actually reflects pure mathematical reality.
And by calculating the gradient or the area under that graph, you uncover entirely new derived quantities. It is literally like discovering new vocabulary in that universal language.
It's amazing. So we have traced the evolution from those 7 foundational letters of the scientific alphabet, built them into complex derived words,
And used graphs to decode the grammar of the physical world.
which leaves you with a pretty wild thought to chew on.
Oh.
Yeah, if absolutely everything we currently understand about the physical universe is constructed from just those 7 base quantities,
Right.
what happens to our entire grasp of reality if we suddenly discover a cosmic phenomenon that simply cannot be measured by any combination of them?
Oh, wow. That would break physics.
It really would.
Oh.
Keep questioning the scaffolding around you, and we will catch you on the next deep dive.
All right, let's go to our favorite section, which is the MCQ. Okay. Ask 10 MCQ 2 by 2 without answer. Explain the wrong answers. Right. So let's start. What is answer for question 1 and question 2? I think it's too easy, right? Let's make it more difficult. SPM level. SPM exam level. Okay, let's try. Okay, you can type your answer or you can tell me your answer. So fast. BB, okay. What about the rest? Wait, okay, you can wait, we have time. Let me pull in the keynotes over here. The keynotes over here. And if you have the picture right in front of you, the picture of the story, then it's even better. Okay. CB DB. Okay. Jovin. CB. So Jing Sam is having different answer, which is D. Okay, let's see. Let's use Jing Sam one. Okay, question 1 is wrong because the answer is C, because this is the answer. Okay, I think it's clear. What about question 3 and 4? Okay, bye-bye, Jovin. 3 and 4. 3 is B, 4 is B. Okay, now we have 3 students. Also B. What about Xuan Xuan? BC. Okay, let me see. I haven't read the question yet. A graph of y against x produces a straight line passing through the origin. What is the conclusion? Okay, let's try B. Inversely proportional and directly proportional. What's the difference? The answer should be C, right? Because inversely proportional means, okay, it will explain here. Okay, you read, then you understand. Okay, I hope it is clear. Now, 5 and 6. Scalar is what? Scalar is without direction. Student plot a graph of force against D and B. Let's try. Let's wait for Xuan Xuan and Eric. D. Eric answer. Also D and B. Okay, what about Xuan? Xuan also D, B, yes. Okay. Correct. Okay. 7 and 8. DC, D and C. B and C. Eric, your turn. B. Okay, B for question 7. Which graph represent an inverse proportional relationship? B and C. Curve decreasing as x increasing. Okay, so let's take D. Okay, let's see what is the explanation. All right. So D is wrong. And why? Why is it B? Why is it not D? This is the answer. Okay. M is mass. Mass is kg. Acceleration is m to the ms minus 2. Right? So that's why it's kg ms minus 2. D is with the minus 1 here, so it's not correct. All right, 9 and 10, last set. Okay. But this 10 question is not easy questions. So far, I think you're getting only maximum 2 wrongs or 1. C and D. What about the rest? Student wants to determine the gradient of the graph. Which pair of points should be used? C and D. What about Eric? Same. Okay, I think you guys did well, very well. It's between 8 to 10. Question correct. Right? So that means you are at the level of 8, 9, and 10. Excellent. In just 2 hours. Oh no, it's not 2 hours. It's less than 2 hours. We started at 8:40. Now it's just slightly more than 1 hour. 1 hour and 20 minutes. Okay. So I hope this helped you and prepare for your SPM or your exam. And let's meet next week. If I'm here next week, then we'll have a class. If not, then the following week. All right. I hope you learned something new today. Thank you so much. Bye-bye.